Okay, so basically this is kind of your show here. I'm not going to go through every single question unless you want me to go through every single question here. I will just give you guys opportunity. And again, we're going to stick to like letters here. So right now, let's just kind of pause and see if anyone has any questions on letter A here. So notice I'm not giving the answers, okay? I mean, we'll give you the answer or whatever kind of thing, but right now it's just an opportunity to ask questions and see if you need to see anything. And again, so the idea is if you have any questions, I'll be to go over. So does anyone want me to go over 1, 2, 3, or 4 here for letter A? So yeah. You do 4. Number 4, sure. Okay. And let's see, that is Jake?
Yeah.
Okay, you prefer Jake or Jacob?
Jake's good.
Jake's good? Okay. So, Jake, number 4. So, and again, Jake, I don't like to just, believe it or not, I don't like to just talk the whole time. So I'm going to ask you some questions too here, okay? And I promise that it will be as painless as possible. All right. So what gave you some trouble here, Jake? Exactly. Or what are you? Why are you like kind of asking about this?
I forgot how to factor the x to the third power.
X to the third, okay. Minus the 8 there.
Yeah.
Okay. Any like is there anything in your brain you're like think maybe it's this, maybe it's this? Any clue, or you're like no idea?
I had written down x plus 2 in front, and then I couldn't remember what to do.
Ah, all right. All right. Good. I can see where you're going with that then. So right, we have this thing called like a difference of cubes or a sum of cubes. In this case, we have a difference of cubes, right? So we have this formula though, right, Jake? So is this kind of like what you're remembering a little bit there?
Yeah.
Okay. So permit me, this is going to like save a little bit of time if I do it this way with the plus or minus. Okay. So a cubed plus or minus b cubed, that factors, okay, always to be a plus or minus b. Okay, kind of like what you have. And then after that, okay, it's going to be a squared minus plus. All right, I'll explain this in a second here. 2ab, and then plus b squared, like that. Okay. Okay. So this includes both the sum of cubes, a cubed plus b cubed. So what is a cubed plus b cubed factor to be? A plus b, a squared minus 2ab plus b squared. Okay? And then for the difference of cubes, a cubed minus b cubed, it's a minus b, and a squared plus 2ab plus b squared, like that. So you just follow the signs, okay? If it's a plus b, a cubed plus b cubed, then it's plus minus plus like that. And then it's minus plus like that. Okay? So that's the idea. Sum and difference of cubes, you will need to know that. Okay? That is something you will need to know. It won't be given to you, you'll have to remember that. Okay? So sum and difference of cubes, make sure you remember that. Okay? So that's one of the big ones there. Okay, so I'm glad you asked about this one, Jake. I was going to point out if you didn't. So that being said then, Jake, how should x cubed minus 8 factor? X is a perfect cube, we can see that. 8 is a perfect cube of what number? 2, right? So I'm going to rewrite, and this can be helpful if you rewrite this for yourself. If you don't need to, but I mean, it might be helpful to rewrite it. So then how should this follow this kind of formula here? Can you do it? So you said you had x plus 2, but we now know it should be x minus 2, right?
Yeah.
And then what should follow that?
X squared.
X squared.
Plus.
So 2 times a, which is the x, times b, which is the 2. So 2 times x times 2?
4x.
4x. Uh-huh. And then plus your b, the 2,
Plus 4.
squared. Like that. Okay? And you know what to do from there, right?
Yeah.
You can do it from there, right? Okay. So the answer is x squared plus 4x plus 4. Because, you know, I'm a math teacher and stuff like that, I also like to include the comma x not equal to 2 part, right? Because the reason why I do that is because really, what equals, right? We're saying that x squared plus 4x plus 4 is exactly equal to this thing up here, okay? That x minus 2 times x squared plus 4x plus 4 over x minus 2. But technically, these two things are not exactly the same, right? Not exactly the same, okay? Here, if I put value 2 in here, will there be any problems with plugging a 2 in here and getting a value for it? No, right? Or if I plug 2 in here, there will be a problem, right? We're going to get 2 minus 2 is 0 times this thing, which will still be 0, over 0. We're going to get 0 over 0. Is 0 over 0 the same thing as, well, whatever this would be? Not exactly, right? Not exactly. And so I like to stipulate that, yes, these two things are exactly the same, as long as x is not equal to 2. Okay, we're kind of doing like a domain restriction there, if I think about it that way. Okay, pulling that out. Because equality really means these two things are exactly the same. So, okay. Question on that? Any questions on anything else from letter A, I guess? Any questions on A? Any other questions on A? Okay, yeah. Number 2? Sure. Okay, so I'm going to write it on the board. I was like, I should be writing this on my paper. So we'll do this one on the paper here. I'll include the sum/difference of cubes right here again. So we'll do the a cubed plus or minus b cubed. And then always positive. There we go. Okay, so there's that. So that's good. Okay, and so question?
I don't think that's right on the board.
Okay, what did I make a mistake on?
Because that's not factored properly. Because if you would distribute the...
Oh, I see what you're saying, yes.
It's,
Did I make a mistake on the sign here?
I think it should be x squared plus 2x instead of 4x. Yeah.
Okay, just plus AB, plus AB.
Yeah.
Okay, my mistake. Thank you. I put that in there, but it should just be 2x there. Okay, that makes sense. Thank you. Did I have that written down right? I did not have that written down right. Okay, so that was my fault here. Sorry about that. And I'll fix that here too. Okay. So just the AB there. All right. Welcome back from summer, you know. So, number 2. All right, number 2. So let's do this one correctly this time. All right, and by the way, I will make this from time to time too. So, or maybe more than time to time. So please feel free to call me out on those. All right. So Clay, what was your goal here with? Well, I already started here. Were you able to factor the numerators?
Yeah.
Okay. So what did you that one to be?
X minus 4 and the next 8.
Okay, x minus 4 and x plus 8. Okay. Let's check that real quick here. So, -4 and the positive 8, they will multiply to make -32. -4 and positive 8, they're going to add, though, to give us positive 4. We need -4. So it looks like we need to swap signs around, and that'll fix it then. Okay? And how about that denominator? What's that?
Me?
Yeah.
Okay.
Mm-hmm.
So I wrote a little bit differently. I did x minus 4, and I used that parentheses. I squared it, and I had to the side x plus 4.
Okay, so you have something like this?
Yeah.
Like that? Okay, thank you. Okay, so how did you get that to factor in that way? Where were you, or how did you see that? I guess.
Not really sure. I think I just need more practice on some of the difference of cubes.
Okay, so first of all, this is a difference. Is a difference cubes though? We have 1 cube, x cubed right here. This is a cube. It's not, right? 16 is not a cube, right? So we can't use the difference of cubes here. Okay, thank goodness, because I made a mistake on it earlier. All right. So what can we do here? Or maybe we can help them out. What can we do here? Yeah, go for it.
Factor out x.
Factor out an x. There we go. The GCF here. A greatest common factor of x. Factor that out. We have x squared minus 16. Like so. X minus. All right. And now that is a difference of squares, right? And so we can factor that too. Like so. Okay. And so what can we do from here?
So then you can cancel out the x plus 4
Yes.
on the numerator and the denominator.
Yeah, exactly. Cancel out those x plus 4s. Cancel the x plus 4s. So there you go. Okay, and then we're left with x minus 8 over x times x minus 4. Okay. And again, I'm going to put in x not equal to -4. Okay. If you don't have that there, I'm not going to, dock you any points or anything like that. But again, when we write stuff in mathematics, we want to be careful about what we're writing. You know, when we say two things are equal, when we say this thing is equal to this thing, we want to mean exactly equal. Well, technically they're not equal at x equals negative 4. Okay, and they're not equal at x equals negative 4. All right. Other questions on letter A? Other questions on letter A? Other questions on letter A? Yeah.
Can you explain why it's negative 4? Just to show us.
Like this, you mean?
Yeah. Why it's negative 4?
Sure. So the explanation here. If you go back up to the next to last step, right? We have this x plus 4 in the denominator and x plus 4 in the numerator that cancel out, right? We're getting rid of that thing. So it's no longer in this problem. Okay. The issue though is that if I were to take this and plug in an x value of negative 4 here, I would end up with 0, right? Times that, which still leaves 0. And if this is 0, and then this all would multiply with that 0, so we have 0 over 0, right? You get the point now? Yeah. All right. So so that's the idea. Whereas here, if I plug in negative 4, no problem, right? It would give me a number. So that's why I like to point that out. All right. Other questions on letter A? Letter A, letter A, letter A. We're all good? Okay. How about letter B then? Letter B. Questions on the letter B? Yes, Chase.
2.
Number 2. Okay. So, any ideas about what to do for number 2, Chase? Any ideas?
I think I got really lucky guessing and checking, but I feel like it's definitely an easy way to do it.
Okay.
I just think it's
Okay, so you kind of just knew that you're going to have two things that multiply back together, so you just kind of guessed and checked and picked something, and then went from there kind of thing. Okay, what did you end up with?
Well, I ended up with like 4. Alright, well, I ended up with parentheses t plus 3, and then parentheses and t minus 3.
Okay, so you have t plus 3, t minus 3, like that.
Yeah, then t plus 2 and t minus 2.
T plus 2, t minus 2. Yeah, that would be your final answer. That is what you want to get. Mm-hmm. Yep, that's it. But now you're asking, is there a better way to do it based on what you did? So, the formatting of this, right, is a little bit funky, right? If we go back to number 1, let's look at that one here first. Number 1, it's a nice, it's a quadratic. Yeah, we have, an A here in front that we have to deal with when we go to factor and stuff like that. But you were factoring number 1, no problem, right? Well, a quadratic, right, is something that's kind of the form A times something squared, plus or minus, I guess, say B times that same something, but not squared anymore, right? And then plus or minus C, right? That's kind of like how we format a quadratic, and you can think of it in that terms, right? So in this case, right, the A is 2. What's the something that's being squared? It's the x, right here. Then minus 13, so we minus 13 there, B would be minus 13. And x, again, the parentheses there, but it's just the first power, right? Just like that there. And then the 15 for the C. Well, likewise, over here for number 2, right? We can think of we can think of t to the 4th as t squared minus 13 times that same t squared plus 36. Do you kind of see what I'm saying now? So then this can factor. We want numbers, since it's just a 1 in front, that makes it nice. So we want two numbers that multiply to 36 but add to make negative 13, and so that's going to be your t squared minus 4, and then your t squared minus 9, like that. And then that factors, because they're both different squares, to this. Okay, and that's your final answer right here. So let me just finish that question. If you don't mind, that'd be great. Yeah. Hopefully you have enough of those papers there. Okay. Other questions? 1, 2, 3, 4. Yeah, Shelby.
For number 3, how
Number 3.
far do you want us to factor?
How?
Factor this.
Okay, so how far did you factor this? What did you do first here?
I did x to the 1/2.
Okay, so you factored out x to the 1/2, and what would that leave in here if we did that? Okay, x to the 4th, like that. Okay.
Plus x squared.
Plus squared, like that.
Yeah.
Minus, sorry, what?
12.
12. Okay. So how did you get this? So I guess you saw that there was a GCF of x to the something here, and you put out the smallest power. Okay. When we're pulling out those powers, we are subtracting, right? So when we factor out x to the 1/2, 5 halves, and we divide that, or we divide x to the 5 halves by x to the 1/2, works out.
I meant 4 halves.
4 halves. Okay, gotcha. And then 2. So this, I see what you're saying. So this 4 halves, and then this is 2 halves, is what you're saying there.
Yeah.
Gotcha. Okay. And then you simplify the fractions there too?
Yeah.
Okay.
Okay, never mind about my
Okay, you got your question? All right, very cool. Okay. And so can we go further here, Sheldon? Yes. What does that factor further to be? plus 4. Okay. All right. Questions on B? Any questions on B? Yeah, Emily.
Number 4.
Number 4. Okay. Did you, please tell me you did not multiply this all out.
I was going to, but I just didn't think that was right. So I
Good for
didn't.
you, good. And it's good for you if you did, but I mean, that's making it really hard if you multiply this whole thing out. So hope you didn't do that, okay? So any ideas other than that, Emily? Just that you you were making it too hard for yourself, and that's good. That's a good,
Well, like,
notion.
they're the same, like, there's two of the same kind of, but like with different powers, so I was a little confused. I don't know.
Okay, so name, what are some of the same things here that you're identifying?
There's 2x minus 3.
Okay, so it's x minus 3 squared here, and there's x minus 3 cubed here. You're saying those are the two right there, right?
Yeah.
Okay.
And like 2x plus 1 is like even squared.
Yep. Yeah. Okay. Good. And these. So this is kind of thing like one thing here. Okay. It's like one product. Okay. It's one term. You can count this kind of as one term here. This is kind of like one term, kind of thing, and they're separated by addition. Okay. So it's similar to this idea right here that we had for number 3, where we had 1, 2, 3 things separated by addition or subtraction, and we factor out a just. Here we can do the same thing. So let's start with those x minus 3s. What's the greatest shared number of x minus 3s that we can factor out?
X minus 3 squared.
Yeah, right, because the first term here has x minus 3 squared. The second term has x minus 3 cubed, so they both have at least 2 of them. So we'll factor out an x minus 3 squared. Okay. And then hopefully, if we're comfortable with this, can I also just go ahead, can we just factor out some 2x plus 1? So then how many 2x plus 1 can we factor out?
2x plus 1 squared.
Yeah, 2x plus 1 squared. Okay. Now we have to think, okay, so what's left, right? We have some things left behind. And you can use like another set of parentheses here. I'm going to maybe use just square brackets just kind of differentiates the grouping. Okay. So what's going to be left behind from this for factoring out these two things? What's going to be left behind from that first term there, Emily?
2x plus 1.
2x plus 1. And what's going to be left behind from, and I'm going to put that in parentheses maybe. And what's going to be left behind from here?
X minus 3.
X minus 3, that's right. Okay. Just like that. And of course we have some addition we can do here, right? We can add these things, they're like terms. So we can put them together. And so we're left with x minus 3 squared, 2x plus 1 squared, and then, let's say, 3x minus 2. Okay? So there's that. So you're right, Emily, there was an easier way to do it. Okay? And sorry to those of you who multiplied it out and then tried to go from there. Questions on B? Questions on B? Are there questions on B? Okay. This little skill right here, number 4, we're going to be using that later. Okay? We're going to end up with situations that look like this. Okay? When we go to take the derivatives of things and we have like this thing called the product rule, we're going to have these like kind of mixtures of common terms like this where we're going to factor them out to help us simplify things much more nicely than trying to multiply it all out and add like terms and stuff. Okay? So keep an eye out for those GCFs that you can factor out. All right. How about letter C? Question on anything from letter C here? Questions from letter C. Got some fractions, right? We love fractions. All right, Lily loves fractions. Which one, sorry?
3.
Number 3. Okay, number 3. Okay. So did you try anything here? What did you try here, Lily? You kind of looked at it and you're like, I don't even know.
Yeah.
Okay. Fair enough. Let me see here if I can like think of some things. So one route. Let's kind of maybe tackle this first here. So we have a positive 1/2. We have a negative 1/2. So for these things like you can't like add these together. They're not quite like terms, right? In order to add things together, they need to be exactly the same kind of thing. So we have to the 1/2 and negative 1/2. So you can't just add these together, right? You get like 3 x to the x plus 1 0, and we have to get these together somehow. So actually, we're going to use a strategy very similar to what Emily just used in the last problem. Okay, we have a common factor here, plus 1. Okay. Now, what maybe gives us a little discomfort is that we have positive 1/2 here, which is no problem. It's fractions, but we can still do that. We don't have this negative 1/2 here. Okay.
Are those exponents or just?
They're exponents.
Okay.
Yeah, they're exponents. Oh yeah, they're exponents. Yep. Yeah. So let's go back to this problem right here. All right. Emily, in this problem, we looked at it, right, and we saw that, okay, there are x minus 3's in both terms, and Emily, because of the greatest common factor, what's shared, she had to take out the smallest of the two powers there, right? So it was to the second, minus 3 to the second. Even though it was third and 2, we take the 2, because that was what most was shared. Here, 2x plus 1's, right, it was 3 and 2, so we took out the smaller power of 2x plus 1 squared, because again, that was what was shared between the two. This one has 3, this one only has 2, the most you can take out is 2. Right, this one has 3, this one has 2, the most you can take out is 2. Let's go back. It's a little bit funkier to think about in terms of fractions and things. This term has positive 1/2, meaning there's 1/2 power of this. This term has this to the negative 1/2 power. So the smaller of those two, right, is the negative 1/2. And so that's what we can do here. That's one option is to take out a GCF of x1 to the negative 1/2. Okay, up front like that. Remember, factoring out, the greatest common factor is division. So let's do the easy one first. If I divide this by itself, what's going to be left from this term, Lily? Just a 2, that's right. So at the end, I'm going to have just plus 2. Okay, that's pretty straightforward, right? Because we're just factoring that x plus a 1/2. But if I take x plus 1 to the 1/2 and divide out, and divide that by an x plus 1 to the negative 1/2. I'm dividing out x plus 1 to the negative 1/2. When you divide two things at the same base, what do you do with your exponents? Not reciprocate. Subtract them. 1/2 minus negative 1/2. What's 1/2 minus negative 1/2? 1. This becomes x plus 1 to the 1. Now, there's other ways to do this. This is not the only way, but I'll say this is probably the most efficient way to do it, right? Or one of the most efficient ways to do it. Okay?
Wait, why is it still x plus 1?
Why is x plus 1? Because the idea is we're dividing here, right? And so these have the same base. That's when we divide out this, when we divide x plus 1 to the negative 1/2, divide out both of these, okay? The bases stay the same, right? If I do x to the third divided by x squared, doesn't that leave just x to the 1? The base stays the same. It doesn't change. Okay, so the same will be true for the base here of these exponents as well, with that division that we did. Base will stay the same. Okay. And so really anything to the 1 power is just itself, so I can kind of drop this and then combine it together, and so I'm left with x plus 1 to the negative 1/2 times an x plus 3, or as we can maybe rewrite it, x plus 3 over x plus 1, the square root of x plus 1, I'll just put it to positive 1/2 like that. Right, exactly right. So yeah, if you wanted to leave it as a square root, or if you want to change it and make square root, that's as well. Yes, and that's important. Remember that too. Again, I should put like equal signs for these things here. Okay. X will be over the root of x plus 1. Okay. So again, some of your teachers, if you didn't have me for pre-calculus, some other teachers may have like required you, to like rationalize stuff, right? Get square roots out of the denominators and things. We don't have to worry about that anymore. Okay? We don't need to rationalize denominators. So we can leave the square root of x plus 1 there. It is still general good practice to not leave things with negative exponents. It really depends. But as a general kind of rule, again, in preparing for that AP test, typically for like a multiple choice where you are not really in control of what the answer should look like, the multiple choice, you're going to look and you're going to have to match your answer to their answer. Typically, they leave negative exponents. They may still, but we still should be comfortable with rewriting from a negative exponent to a positive exponent there. But if this was like a free response question, I would be absolutely fine with you stopping right here. Okay, no problem there. No problem. Technically, you could stop right here and be okay too, but anyway, this is, not really a typical free response question. So, all right. Does anyone want to see it done the other way, using like fraction stuff? I can do it with common denominator. I want to see it that way. Okay, because you could do it by making these into fractions with common denominators too. Okay, so I don't know if anyone tried it that way. Did anyone try to do it that way, or did it that way? Yeah, and you guys got it okay stuff? Cool. Very good. All right. So, just as a real quick. So if we rewrite that x plus 1 to the negative 1/2 as 2 over x plus 1 to the positive 1/2, now you can see we have fractions, we need to get common denominators. What's missing from this denominator, this 1/2, is missing the x plus 1 to the 1/2. So we'll just multiply by x plus 1 to the 1/2 over x plus 1 to the 1/2. Okay, we get our denominator that we want. And then x plus 1 to the 1/2 times x plus 1 to the 1/2, same base, add the exponents. Okay, when you add fractions, right, the denominators stay the same, so we're going to have our denominator there if we want. I know no one asked to see this. Let's see anyway. And then x plus 3. Okay, so there it is. Alternatively, right? But maybe no one wants to see this because they're like, oh, this is so much better. But, you know, this is okay too. This is not wrong. Okay, this is not wrong. So, other questions? 1 or 2 from letter C? 1 or 2 from letter C? 2? Okay. So, any ideas about how to start it there?
Yeah, for like the denominator, I set it up, it put 1 underneath and 1 so I could like get a common denominator.
Okay, so 4 over x over, and that's okay with you. I'm going to go ahead and rewrite that 1 as x squared over x squared to get that common denominator, just to save myself some space. Is that okay? Yeah. Jump in that. Okay. And then, what can we do from here? Now we have a common denominator.
So you have x squared minus 2, x squared, which simplifies this to 2.
So, yes. Okay. But you wanted to then go ahead and cancel x squareds, right?
Can I do that?
Right, good question. So, can we do that, right? Let's think about it this way. That's a great question to ask yourself. Can I do something, right? And so when you were doing this problem, Clayton, were you wondering, like, if you could do this, or you just kind of just go ahead and do it kind of thing? Or you're like, maybe I can do this, maybe I can't? Which way were you?
I was like 70% sure I could.
Okay.
Anyway.
So here's the thing, right? In a situation like that where you're like, I'm not really sure, right? Because Mr. Whitmire's not always going to be there, like, looking over your shoulder saying, you do that, or whatever kind of thing. What can you do? Well, you can make up an easier problem for yourself, okay? Like this, all right? So now I'm going to use numbers, right? So I just replaced the x squared. I left the minus 2 in there still, but I replaced x squared with 3. Just, you know, we'll just put a number in there. Because x squared just represents a number, right? What you want to do is you want to take that 3, and you want to cancel these out, right? Leaving behind, I would assume like a 1 like maybe. 1 minus 2 is negative 1 over 1, so you want to say that's negative 1. Okay? But 3 minus 2 is 1 over 3. Right? So clearly the question is, we know this is right. Minus 2 has got to be 1/3. So can we cancel these out like we want to? No. Okay? And so that's what, a strategy you can use if you're on a test or on your own or something like that. You're like, can I do this thing? Try replacing some of the variable numbers out like, So anyway, so we can't do that. What can we do at this point then? Well, when you divide fraction, it's multiplied by its reciprocal. So 4 over x times x squared over x squared minus 2. Okay. I messed up some difference of keys. So we'll fix it though as we go. I know you sent me a warning too, so that's on me. That's on me. All right. So there. So we can simplify from here. Now, Clayton, you can do what you want to do. Cancel some things, right? X squared and the x, those cancel, and we have then 4 over x squared minus 2. Just like that. And again, technically, I should say x not to 0 here because I think that would have... Did I make a mistake? Yes, 4x, thank you. 4x. That's not something we can Thanks for that. Yep, 4x. 4x.
You don't need to simplify like then you take an x. Can you do something with the exponent of x? There's 4x over x squared.
Yeah, the problem is here in the denominator you have x, but then this 2 has x. So there's no way to kind of factor out an x from the denominator there. Again, it's separated by addition subtraction, so you need to do like a GCF kind of deal. If you could, if there's x, then you have x squared minus to pull an x out and cancel with it. We don't have that. We can't. Number 1. You want to see number 1? All good? All right, last one. D. Last hit today. Just A through D. Just A through D. Okay. So any questions on letter D here? Yeah, Sean. I was gonna say certainly someone's gonna ask about number 9, right? Okay. I don't know why I'm erasing this. I'm gonna write it on the paper. Okay, so number 9, we've got this thing that we want to evaluate. Okay, it's made up of I like to think of this in 3 different pieces here. G plus h. Let's subtract then g of x from that. Whatever g of x plus h is, we're going to take away g of x from that, and we're going to divide that whole quantity by h. So again, I like to break it up. I'm going to say, all right, what is g of x plus h? Okay, so the x plus h, that's in parentheses there, so it's going to replace the x up here to be 2 times x plus h plus 1. So again, I'm just, what is that g of x plus h? G of x plus h, 2 x plus h. The x plus h is in parentheses, it replaces x inside the parentheses, and so therefore it replaces this x and xh, right? Okay, plus h plus 1. Notice the plus h is not tacked onto the end, right? It's not x plus 1 plus h at the end. X plus h is all in the parentheses, so that means that entire quantity goes in for the there, okay? Common mistake there that I see. So now we're going to do g of x plus h minus g of x all over h. We know what g of x plus h is. It's that 2 times x plus h plus 1, okay? Minus quantity g of x, which is 2x plus 1, all over h. Okay. This is preparation for one of like the fundamental definitions of calculus, the definition of the derivative. Okay, the limit definition anyway, the derivative. All right, and so this is something we want to be comfortable with, at least early on. But it's something that we'll see throughout the course, kind of in like a different kind of way. But we'll really the major focus here in the next, in the coming, not too long, distant future. Okay, so pretty soon. All right. So Sean, I'm assuming that was like the major kind of like the substitution there, which was the most difficult part for you. You got that? Okay. Oh, you know what to do now. Ah, okay. And no idea? Eventually. Okay. So we have the 2 here in front of the parentheses. Distribute it. We have a minus in front of the parentheses, so we'll distribute that. So we minus 2x minus 1 all over h. You see anything else here? Yeah, 2x's cancel. Positive 2x minus 2x. Plus 1 minus 1, they cancel. We'll have a 2h over h. And then we can finally cancel the h and we get 2. Okay, just the 2. And again, I mean, technically, I guess we could say, h not equal to 0 there, but. That's the idea. That's the only one I really wanted to go over there. Not that I don't want to go over the other ones, but that's the only one. If everyone had stayed silent, I would have gone over number 9 for sure. But I'm happy to go over any other ones there too. So, any other questions? Any other questions on letter D? Okay. Very good. All right, so what I'm going to do now then, so again, tomorrow we'll be going over the rest of this, I think, or at least up through, let me check my calendar here. Tomorrow we're going up through E, F, G, H, and I. All right, so that is not the entire packet, right? We still have L, M, and N. That'll be coming up next week. Okay, and then of course our quiz on Friday. If you'll notice this too, quiz is only going to cover up through F. Okay, only up through letter F. So that means there won't be any big on the quiz on Friday. I know that you're disappointed by that, but don't worry, we'll get to the tree stuff later. Okay, but it's going to cover up letter F. In the meantime, we're done. You want on your homework for tonight, okay? Your homework for tonight is worksheet 1. It's on Google Classroom. Worksheet 1 also has a few problems of book in it too. So just keep that in mind. You just do your worksheet on a separate sheet of paper. Okay. 1 second.